For oxidation state, you should have said something about the charge that it takes on or that it would take on if the most electronegative guy grabbed them. Okay. So you could have said the charge it takes on, the charge that it would take on. Okay. Galvanic cell, something about that it produces electrical energy from a redox reaction. Something about that. Electroplating is where you use reduction to coat an object with metal. Corrosion is deterioration because of oxidation. Okay, number 2. The odd compound following unit structure which breaks the rules you learned. Use the definition of oxidation state. Determine the oxidation state of the phosphorus atom. Oh, so you just went through the process you learned and found that it was 5, plus 5. Good.
This is pretty.
Yes?
If I've done the wrong charge but I got 5, how much should I take off?
Oh, take off half. Okay. Okay. And what is half? Hang on, I'll tell you. So it'll end up being 2 points because they're each worth about 4 points each. Okay. Okay, let's see. Then we go to 3. Give the oxidation state for each atom in the compound. Ooh. Okay, let's try this. This one gets a 0 because it's a homonuclear diatomic and it has no charge. This one, the first one that hits one of the rules is hydrogen. It gets a +1. There's 2 of them, so this would get a -2. Calcium is a +2 metal, and this is a -2. The whole thing equals 0, so we have +2 plus 2 times nitrogen, whatever that is, plus, and this is 6, 2 times 3 is 6, times -2, which is -12, equals 0. This whole thing equals 0. So then this will come over here and make this a -10. So 2n plus -10. Then we're going to bring this over here, 2n equals 10. So n equals 5. So nitrogen is going to be a +5. Okay. This one, if you follow the rules, the first rule you hit is fluorine. It gets a -1. These get a +1. So this is going to be 2 minus 2 equals 0. So carbon is a 0. Yep, carbon's a 0. Okay. Number 4. For each of the following reactions, indicate the atoms being oxidized, the atoms being reduced, and the oxidizing agent and the reducing agent. So, okay, first we need to find their oxidation numbers. This is going to be 0. This is going to be 0. But this is going to be +1, and this is going to be -2. Okay. Now, we can look at this and go, sodium goes from 0 to +1. So sodium is losing electrons. Therefore, sodium is being oxidized. And we see that this goes from 0 to -2. So oxygen is being reduced. And O2 is actually the oxidizing agent. And sodium is actually the reducing agent. Okay, this one's going to have a 0. That was easy. It's the easiest one there. This is going to get -2. There's 2 of them, so that's -4. So this is going to be a +4. This is going to be +1, -2. So over here, this is going to be +1. This is going to be -2. So we have 2 times that. So that's going to be plus 2. 2 times that, so it's going to be negative 4. So what's nickel have to be for that whole thing to be true? 2 times 1 plus 2. 2 times negative 2 minus 4. So this becomes negative 2. So nickel has to be plus 2, doesn't it? Yep. And then this one we have plus 1 minus 2. Same thing as before. So we have a negative 4 plus 2 equals 0. So cadmium also has to be a plus 2, doesn't it? Yeah. Okay, just going to get rid of this. Now, let's look at this. We go from 0 to plus 2. So cadmium is losing electrons, and therefore cadmium is being oxidized. And here nickel is going from 4 to 2, so nickel is being reduced, and therefore the nickel oxide is actually the oxidizing agent, and the cadmium is actually the reducing agent. Okay, this is going to have a 0. This is going to have a 0. This guy's going to have a plus 1 because it's a group 1 metal. This guy's a minus 1. This guy's a plus 1. This guy's a minus 1. Let's look. Chlorine goes from 0 to a minus 1, and therefore chlorine is receiving electrons. It is being reduced. The iodine went from a minus 1 to 0. It's losing electrons, so the iodine is being oxidized. And so the potassium iodide is the reducing agent, and the chlorine is the oxidizing agent. There we go. Did you guys already check these without me? No. Okay. So you're going to draw the cell. So you're going to go like this. And we are going to put the anode on this side. And we're going to put the cathode on this side. And we're going to put that the flow of electrons goes this way. Right? And we're going to put a salt bridge in between the two. And we have an electrode on the end of each of these. Okay, so that's our standard galvanic cell. And then we look at this and decide who is doing what. And from the left side, chlorine is 0, and on the right side, it's a negative 1. So chlorine is being reduced. So it's going to go over here. So we're going to put the Cl2 over here. And then, oh, and this is an electrode. You could have written that. Okay, salt bridge. You probably wanted to write that. This is the flow of electrons going that way. Okay. And then the iron goes from 0 to plus 3, so it's being oxidized, and so you're going to put the iron over here. Okay. Now, you could have put that this electrode is iron, but don't take off if you didn't. Okay. If you got that much, I'm a happy camper. Okay? All right. Let's see. Number 7. Number 7, is the following redox reaction balanced? Okay, remember, it looks balanced, but you're looking at electrons. So this has a plus 3 oxidation number. This is 0, and this is plus 1. So that means potassium is losing 1 electron, but here aluminum is gaining 3 electrons. So this equation is definitely not balanced. The answer would be no. And he doesn't ask you to balance it, but I just want to show you, you would need 3 of these, and then you would have the 3 electrons being given from here to this guy to make this true. But that's not what's there, so your answer should just be no. Number 8. This goes from 0 to +1. This goes from +4 to 0. So this guy has to be giving 4 electrons away. This guy excuse me, I'm so sorry. This guy is receiving 4 electrons, but this guy's only giving away 1 electron. Well, wait a minute, there's H2. We have to balance the actual molecules. There we go. So there's 2 electrons being given here. 2 electrons are being given. But here, this guy's receiving 4 electrons. So we're going to need twice that, aren't we? Now that we have 4 electrons being given away, and this guy's receiving 4 electrons, then that's balanced. So that's what it would require to balance that one. And it's either right or it's wrong. I'm sorry to say that, guys. Let's see what it's worth. I guess each one's worth 3.5 points. Yeah, so that one is worth 3.5 points. So you just have to take it off if you didn't get that right. But you were balancing, you have to balance the atoms, but you also have to balance the electrons. So that's what you were tracking.
In the diagram, it says which object will get electroplated with silver, the circle or the triangle? It would be the triangle because it's the one that's attached to the anode. On number 10, which type of battery can be recharged? That would be an alkaline battery. Number 11, which of the reactions is the one that powers an alkaline battery? That would be A, because it's the only one without an acid in it. That's why. And then 12, does a dry cell have any water in it? Yes. Remember, it's got a paste thing going on. Okay? All right. It's got each problem worth 4 points. Hang on. But the number 5 is actually worth more than that. Did everybody get number 5 all right? Yeah. Okay. Otherwise, you need to go in and look at the book to figure out how to do number 5. Yes?
On number 3, you know how you because C and D, you had 3 of them that you had to give their oxidation state. Like, what if you only got 1 of them wrong, but you got the rest of them? And even the charges were fine. It was just a matter of...
Okay, so you missed 1 out of 2 on B?
No, not B or A. I missed C or D.
Okay.
3 of them, and they're all...
So so just take off 1 point for each thing that you missed. Okay? Okay.